Water is pumped into the tank at a rate of R of t equals 30 times 1 minus e to the power negative 0.16 t, and that's measured in gallons per minute. So it's important to recognize that this is a rate function, and it says where t is the number of minutes since the pump was turned on. If the tank contained 800 gallons of water when the pump was turned on, so that then represents the initial amount, or the G value, the number of gallons at t equals 0. How much water to the nearest gallon is in the tank after 10 minutes? So again, we've been given a rate function and we're being asked to find the accumulation of gallons here. So it's going to look like this. We're going to calculate the gallons as a function of time, and that's going to be based on the starting value. The starting value is 800 gallons plus the area, or the change, from t equals 0 to t equals t. And that's going to be underneath that rate function. R, in this case, I'm going to change that to x, r of x dx. Okay, so this is our general function, and we are going to find g of 10. We're being asked for the number of gallons at 10 minutes. So we're going to start with 800 gallons, and then we're going to add the change in the number of gallons from 0 to 10. I'll just kind of make sure that's red, so I'm going to color that area in red. That's underneath the R function. So what I'm going to do is I'm going to graph this. Now this could be done using an antiderivative, because we can anti-differentiate this, but this is typically on a calculator section, so we're going to use our graphing calculator. So we're going to graph this function r of t in gallons per minute, and what we need is the area underneath this curve from 0 to 10. And this area in here is going to represent the displacement, or the change in the number of gallons from 0 to 10 minutes. Okay, so putting this in the calculator, so we're going to graph this on the graphing calculator. When we put this into the graphing calculator, we're going to use the integration function. So when we integrate this function, we should get, from when we integrate from the lower bound of 0 to upper bound of 10, we should get an accumulation of 150.35559, which we're going to round to 356. Okay, and this is measured in gallons. So this then works out to be the G of 10 value is going to be the starting amount of 800 gallons, and then we're going to add on the amount of accumulation here, which is going to be 150.356 gallons. And so this works out to be, when we add this together, this works out to be 950.356. And that's measured in gallons. Okay, so again, this represents an accumulation function where we have the starting amount plus the area under the curve represents the change that we're going to add on to find the y coordinate, or the g value, at g equals 10. The second part of this problem, it says after 10 minutes, the water is leaking at a rate modeled by L of t, which is 0.05 t squared plus 0.1 t. So how much water is in the tank at 20 minutes? Okay, so there's a few different ways we can do this. We can just start at 10 minutes, since we now have the value, that the number of gallons at 10, and then figure out how much is added in under the G function, sorry, the R function, and then we can take away the amount lost under the L function. Okay, so we're going to maybe do it that way. So we're going to start with our starting value, G of 10, and that's going to be, we're going to start at 950.356 gallons. And then to figure out the amount at 20 minutes, it's going to look like this. So the G of 20 is going to be equal to the starting amount, which is 950.356. We're going to add in the accumulation from t equals 10 to 20, and that's going to be underneath the R function. That's what's coming in. And then we're going to take away what's coming out. So it's going to be minus the area from 10. So it's this function starts leaking at t equals 10, from 10 to 20 underneath our L function. And again, I'm just going to keep this variable as x just so that it doesn't conflict with our t. So L of x dx. Okay, so what I'm going to have to do is I need to find the area underneath that curve, and I'm going to do the blue one first. So from 10 to 20, the blue area is going to be the accumulation from 10 to 20. Okay, so putting that into my graphing calculator. Again, we're starting at 950 gallons. And then we're going to add in, well, using again the integral function on the graphing calculator, we're going to calculate that to be 269.7873 gallons. Okay, so we're going to add that in. So 269.787. And then we're going to take away the area under the curve, under the red curve. So we're going to again use our integration function. In this case, I'm going to find this area in here under the L function. Okay, and again, using integration function under the L function, this is going to be, we're going to lose 131. So I'm calculating this to be 131, and I'm going to subtract that because we're losing that, 131.6 repeating. So I'm going to round this to 667. Okay, and so at this point, we just need to sum this all up. Okay, we're going to put this, just add it all up. So on my calculator, we have 950.356 plus we're going to add in 269.787, and then we're going to lose 131.667 from leakage, and that gives us a net amount of, and that looks like 1,088. Okay, so I'm going to write this down. So G, the amount of the gallons at 20 is going to be 1088.476, and that's going to be measured in gallons. Okay, so the area under the rate function is under the rate per gallons per minute is going to be measured in gallons. So this unit is in gallons.